Hello, 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 hello. Okay. So I am recording this, and this will take a little while. And those, you're trying to get it in by midnight tonight. It may not get posted till 10 because it's going to be an hour long, and it takes YouTube a while to put that up. Probably good that you don't have your video. Nobody has their video on. That's probably good because this is going to go on publicly on YouTube. But it won't probably be up and ready till about 10. But if you're here, you're going to get it live. So, well, this is not just me working the test. This is you asking questions. And if nobody has questions, then we'll cut her short on the take-home test. And it could be on something we already talked about. That's fine. It could be clarification. And I think I can hear you. I can't hear anybody right now, but oh, let me open up the chat. Hold on. Now I don't have my big screen, so I'm kind of limited on screen space here. But it looks like nobody's really said. Oh, hello, okay. So Tipton said 13. Okay, so since Tipton started us off, we're going to look at 13. And 13 we have talked about, but this is the, whoa, sorry. I got to share the screen. Hello. Let me share the screen. Coming up. Yeah. All right. So this is, and now that I share the screen, I can't see the daggone chat. Oh, great. This is the problem with not having another screen to look at. I'm not at school. I'm in the box room. So how can I do this? Hold on. Maybe there's a way to look at both. Let me open up chat again. Okay. It's tiny though, guys. I can't see it very well. Hold on. Okay, I don't need to see that. All right, here we go, Tipton. I can now see your chats. And don't even turn your cameras on because not that you were. All right, so this is 13, and just, okay, hold it, that's weird. So this is 13. This is what we talked about on Wednesday morning. It says answer in at least 30 words why it is sort of lying to leave a measured number using instruments in terms of a fraction. And we came up with the idea that, well, what if you saw something moving across the table at an angle? And so you knew where it started, you knew where it ended. And so you measured horizontally 3 meters with a ruler, with say a big meter stick, a tape measure. And then you measured 2.0 meters. You go to the nearest tenth of a meter, okay? Nearest 10 centimeters, best you could do. And then you're dividing out what let's say you wanted what the slope of that line was with measured numbers. And you got 0.66666. This is 2 divided by 3. And if you wrote down 0.6666666, that would be wrong. I mean, it'd be right, but it would be fraud. So you have to, because you're misrepresenting your data. You're not telling the truth. And in science, you have to tell the truth, not like politics. So here you could say you have to say, well, is it 0.666? Is 666 or is it 0.6? Well, because the 2.0 only has 2 digits, 2 significant figures, the 3.0 has 2 significant figures, the answer can only have 2 significant figures. Now I realize I'm putting the cart ahead of the horse on significant figures because that's something that'll keep coming up. And I kind of want it just to come up naturally, but I think you can answer this question at least. What I gave you there was 50 meters over 21 seconds as an example. And if you divide that out, you get 2.38095238 meters per second. But I see too many students leaving that kind of stuff on their calculator. And that is, that's bad. It's bad form to leave the number like that. That's something you do in 5th grade. So we got to stop that. And just, you got to say, well, how many digits? Now, technically, this has, because it's 50 divided by 21, 50 really only has one significant figure, so your answer would have to be 2. But so 2 meters per second. But I'll certainly take 2.4 because we don't know enough yet about sig figs. But 2.4 meters per second. In other words, you can only be as accurate as your least accurate number. To make that 50, over 21, to make that 50 have 2 sigs, we would have to say 50 point divided by 21, so that you would know that 0 is not just a placeholder. Let's see, I quickly get into the weeds here with sig figs, which we could spend a week on those. And you're not going to have to worry so much about sig figs. In AP chemistry, you do quite a bit. And then in PChem, which you'll take as a junior in college, you really got to deal with them a lot then. But it's just, to be a good scientist, I'm trying to teach you to be a good scientist. You have to be aware of the accuracy of your instruments. That's the main point. That it's kind of lying because you're saying that your instruments are more accurate than they are. Okay. So let's go with the next question. Oh, unless Tipton or somebody else has another question on that, I would love to discuss it with you. So ask a question on 13.
Do we have to do this question like this, or could we actually write it out in words?
Oh, certainly, Brendan. I want you to write it out in words. This here is a hot mess, I think is what these kids say these days. And if I saw this, I mean, I've been explaining it, but I'm not writing it out in nice essay form. If I saw this from you and it's worth 4 points, let me be honest with you, I'd probably give you a 2 out of 4 because you never really explain what the heck's going on. I mean, I see all these numbers and, well, what is going on here? So you're right. Good point, Brendan, that you would have to, in addition to this, you don't need all this stuff. You could just write it out in a paragraph form. It says 30 words. That's a short paragraph. That'd be fine. So Elizabeth asked the question before I see yours, Harun, but let's get to Elizabeth's question. She said, so 0.6666 would be a fraud because it does not have the same amount of sigs. I'm still confused on that part. When you answer, when you use your instruments, you want to show how accurate you were. Now, if you said, if we're taking these two numbers, let me get my pointer here. If I'm taking 2.0 meters divided by 3.0 meters, now I said 2.0, 3.0, that's 2, right? That is 2 digits, 2 significant figures. I'm as accurate to the nearest tenth. And then I go and say 0.6, like you're saying here, Elizabeth. I say 0.6666 as my answer. That would be fraud because I am saying that my instruments were more accurate than they were. I'm saying I can go all the way to the nearest 10,000th position when in actuality I can only go to the nearest tenths. See what I'm saying? So you'd have to answer that as 0.67, and this is whatever. Well, in this case, it's meters over meters, so it wouldn't have any units if I was doing this. Now, if I'm doing the 50 divided by 21, that'd be, 2. It should be 2. I'll take 2 or 2.0, but the meters per second would be the units there. Does that help, Elizabeth? Okay, we can come back to that if we have time at the end, but I want to get on to 14A. Harun asked about 14A, and so that's a good one. We even looked at 15. We looked at 15, and so it's similar, but since he asked, let's look at 14. So 14A, let's go ahead and just do 14B while we're at it. So you start, these are really important questions. You start at a point in the hall outside room 807, 18.0 J roof meters, and that's about right outside my room. Remember, for those that did the hallway thing, that's right outside my room. And run a slow jog for 10 seconds, okay? You end up right in front of the custodian's closet, so you're all the way, you're heading south, and you end up at -2 meters, or -2 J roof meters. Notice you can say You can say it either way. You can say -2 J roof meters, or you can say -2 meters J roof. It does. I've seen it both ways. To me, it doesn't matter. You might have a stickler for details in college, and she or she may care, but I don't. To me, either one of those. I've seen them both ways. So you write the equation. Write the equation for your jog. Okay. Well, it told us where we start, so I go for that low-hanging fruit. I'm going to stick that on there real quick. Where we started. We started at 18.0. I'll do it like I did in the problem. J roof meters. So that's my. We're going to say, you know, Y of T equals VYT plus Y naught, and Y naught means Y original position. So that's my Y naught right there, 18. All right, and then we do a slow jog for 10 seconds. You end up right in front of the custodian. So we end up at -2. So I sometimes a little drawing helps, kind of, you know, people get nervous on tests and stuff. So it helps a little drawing. 18 J roof meters to -2 J roof meters. Okay, we got 20 meters, right? Backwards 20 meters in 10 seconds. Well, 20 divided by 10 is 2. So we say negative, right? Because I'm going negative direction, heading south. -2.0 meters per second, J roof. Now, okay, and then this says equals Y of T. And if I leave it like that, I am going to get, let's say we're 6 points here. And if I leave it like that, I would get a 4 out of 6. Why wouldn't that be a 6 out of 6? I have my V. I have my initial position. Why wouldn't that give me, you know, 6
You don't have the T.
Say it again, Eric.
You don't have the T.
Right, so I have the T. Oh, okay. I hear you. I'll put the T in. Hold on. Let's put the T in. Hold on. Plus, times 10 seconds plus 18 J roof meters. Now it's right? Anybody disagree?
Don't you need parentheses?
Parentheses are okay.
Wouldn't you need to keep T as just a variable?
There you go. All right.
Good.
So give yourself a zoom point. So I was checking to see. Now that's a common mistake that I don't want you to make. So that has to be a T right there, because you have to keep it, like you said, you have to keep it as a variable to make it an equation. If you put in 10, as a lot of students do, you've given me 1 point, but I want the whole line, you know? Okay, then it says plot the graph. And the graph now, we've been doing this since almost day 1 in class. So we go to 18, that puts me way up there. There's my 18J. And it's going to go a slope of -2 for 10 seconds. So we know it ends up at -2J, which puts me down here. And then all I got to do is connect that up. Okay, and feel free to change your answer. It's called a take-home test, but it's really a glorified homework assignment, 75-point homework assignment. Whereas most homeworks are worth like 15, 20 points, it's 75 points. And it will very well prepare you for the test. If you keep asking questions like you're doing. I mean, I'm preaching to the choir. You guys are here on a Sunday night, so. All right, yeah, so Jacob's pointing out that it had to be a T. Gotcha. What else? Is that it? I think that's it on that one, right? That's it. So that's the kind of questions you'll have probably 2 of these, one involving iRoof, one involving, here's the one we did on Wednesday morning, right here. And that was a little harder because that one, and I screwed up, you'll see it on the video when I first did it, but that was a little harder because we weren't given our initial position. We had to go back and kind of figure, see, we had to use this, we had to go mess around with this to find that initial position. So that's 15 was harder than 14. Okay, now Elizabeth, we'll need two of you now. Say, let's go back to 3B. So let's go back to 3B. Okay. Once again, graphing stuff here. Graph the following two situations, assuming the origin is the sidewalk by the science lot and south is the positive direction. Now, we were virtual the first couple of weeks, so I had to kind of change this, and because I couldn't get Wi-Fi in the west lawn, I had to go in the hallway. So this one, you don't have any direct experience with this. I apologize, but it is what it is. So here we go. They said 3B. Okay, let's go ahead and do 3B then. Okay, so it says Adam starts 10 meters to the north of the science lot and to the north, 10 meters to the north of the science parking lot sidewalk, thank you, and runs south at 3 meters a second for 12 seconds. Okay, so we're saying because of logistics, every year I have to make, in this case, and this is kind of weird, but I have to make south positive, and normally south is negative. That's the, and north is negative. So, when we talk about reference points and all, and when you set up your axes, you're the one who decides how you want to do it. So in this case, because it came down to, because it's just logistics, traffic down, I couldn't make the other way around. So south now is positive. And so Adam here is starting 10 meters to the north of the science lot. Well, his initial position is actually right here. It's at the negative 10 meter mark. And he's running south, so he's running positive for our axis, he's running positive, and runs for 12 seconds at 3 meters a second. Well, 3 meters, so we have the situation, delta, get that out of there, We have delta x equals v times t, that's our red equation. And so we have, so we have delta x equals 3 meters a second times 12 seconds. So I'm going to make mistakes like I see students make, and you guys correct me, okay? So you go, okay, well, looks like at 12-second mark, I'm at 36 meters. Okay, then you connect those up. Well, what mistake did I make?
We have to subtract 10.
Right, because I went 36 meters, but I was started at negative 10, so I ended up at 26 meter mark at the 12-second mark. So I'm kind of guesstimate that. That's 26, puts me about right there. That's okay. This is just, doesn't have to be perfectly accurate. And then you just, yeah. So I'm going to get your ruler out. So I don't want to see, here's what I don't want to see. This is slop. I don't want to see this kind of stuff. Old shaky hands, all right? You can do better than that. So get a straight edge, get your paper, get a ruler, your phone or something, and give me a nice, crisp line. And I think that would do it for B. Let's make B as in red. So then if you can do that one, you can probably do A. We'll leave A up to you. Now it's okay for you guys to compare answers on Facebook. I thought I'd get a little more Facebook action this weekend. I've had limited access to the internet until got home tonight, but you all need to, it's okay. Okay, on Facebook, when you're working on a problem, one thing I don't want you to do is just give answers. That doesn't help anybody. You can certainly take a picture of your work and then put it on there and say, hey guys, does this seem right to you? That kind of stuff's okay, but just give me an answer. Giving somebody an answer, I'll delete that. So I want to see you help each other, not just give each other answers. Okay, so we did 3B. Any other questions on the take-home test? So Evan's asking me a detailed question here. He says, I think I understand 1. Let's go back to 1. and thank you, Evan, for asking about one. I thought so. I wonder when somebody's going to ask that. This is what I've put so far is being motionless is just staying in the same position compared to another point. And like me staying in the same spot in my room since my room is moving at the same speed I am. So there you go. There's the key word there. So you said, so in relation to my room. So you always have to say relative to a point, relative to this pin, I'm not moving right now. Okay, even though the pin and I are both moving, I'm not moving relative to this pin. I would be motionless. Am I going the right? Yes, you are going the right direction. I think we ended up, we came up with the definition of motionless, and we said motionless means moving at the same velocity as your reference point, which is a weird way of saying it. You define motionless by saying the word moving, but that's only because we finally threw in the white flag on you're always moving. There's no matter what you do, you can't help yourself but move. So you have to make it relative to something. And so, Evan, if you had written this, I would have given you 3 out of 3 points out of 3 points. Okay. So 2 we've talked about on Wednesday. 3 we just talked about. 4 we talked about on Wednesday. I'm not saying we can't go over 4A or B. We talked about 4D. Metric stuff, we did 12. I think that's the hardest problem on there. But feel free to ask another question. 13 we went over already today. 14A we did it. This thing on the test. October 13th is, remember, I'll never move the date up, but I might move it back because of all the, are we going full time? And then there's so much going on right now. I want to do it October 13th, but I wanted to do it October 8th, but then I realized, that's fall break. So October 13th, it could be as late as the 15th. May even get pushed back to the 15th, question mark. But as we get closer, probably this weekend, I'll know. Because we got to get through 1.8, and we're going to start 1.7. 1.7 is not hard. It's just more metric stuff, except there is the section at the bottom, which is new. So you can go ahead and do 1.7 right now, 1 through 20. That's just the same. It's good practice for the test as well. 1.7 is, a lot of it's just like 5, 6, 7, 8 on the take home. But there is some new stuff, which we'll get to later on. Probably maybe the end of the day tomorrow, at the end of the period, or certainly on Thursday or Friday. And we also got to get through 1.8, and 1.8 is kind of tough. So 1.8 is one of the harder sheets. So I don't know if we'll get to everything by October 13th. We're just going super slow, but I'm showing you, this is 16, the unit analysis here. When will you assign the Chapter 1 test? And it's interesting you say assign, because that's what Mr. Pentecost and I are right now debating, is to how do you give an in-class test. If the district carries through with their threat and makes us all be in person, which is crazy with all the COVID going around, but it's good. It's good physics-wise. It's good for learning. It's just bad for staying at a hospital. But if we're all together, then to answer your question, Harry, we would be taking the test on either the 13th or the 15th in class. Now, virtual kids will do that through Zoom, and I'll watch them, I guess. I'm not sure that's going to work. But if we're all virtual, then I got another plan for that, but let's wait and see. Okay, Elizabeth said, could you go over 16 a bit more? So here's 16. These are the steps we did. I can't reverse this. And this is more like the kind of problem you'd see. There'll be two. Okay, so here's the one. Here's the easier one. Always test A. Take-home test A is always easier than take-home test B. take-home test B, you'll probably get Thursday of this week, and you'll have at least a week to work on it. And we'll do a. Oh, okay. The Wednesday before fall break, we have a office hours. So I'm going to do another hour during that when I can help you. And then I'm talking about test B. And then I'm not sure when it'll be due. So I'll be down in Austin, Texas, and depends on if the place I'm staying has very good Wi-Fi, whether we could do another one. Anyway, so back, let's talk about 16 for a second. Oh, Haruna says, when's 1.6 due? That is due at the early, right now it's set to be due on Tuesday. If you look at the campus, it's set for Tuesday. That totally depends. That totally depends on what happens tomorrow during first and third hour. If we get far enough, which we might, if we get far enough on it that I feel like you guys can then finish it all, we'll go ahead and keep it due on Tuesday. Oh, okay. Jacob says, I already moved it back. I had originally date was Tuesday, and you're right, Jacob. That reminds me, I did move it back. Like I say, I'll start moving these things back. I think I wanted to do that. I wanted to move it back to Wednesday night so you guys had a chance to ask questions on it during the office hours. So it's not, you're right, it's not due Tuesday, it's due Wednesday. Yeah, that's what we're thinking right now. Yeah. So until we hear otherwise, it's due Wednesday. It could be Wednesday or it could push back to Friday, but I don't know. Okay, so Elizabeth asked a question a long time ago. She said, could you go over 16 a bit more? Let's erase this stuff. So the point is that on take-home test 1A like this, it's not as bad. The one on test 1B will be a little harder than this. But let's worry about that when we get it. Yes. Yes. Can you hear me all right? You guys can hear me, right? Yeah. So here we go. So first off, Elizabeth, you're the one that asked the question, what that we have so far, what is not making sense? Look at this problem here, and you can type it or you can turn on your mic and ask it, but what is not making sense so far? We've done, it looks like we've done down through step 5 or 6 of the 10-step process, you know. We've done the first, I think, 6 steps. If you stopped right here, you'd probably get a 5 out of 8. Oh, okay. So she said, I'm just not sure where to go off from where you ended. Okay, so good. So thank you for that clarification. So everything else on here, and I'm gonna do a different color. I'll do red for these. Everything else on here is a conversion. Okay. Now conversions are clever forms of 1. And so we got to end up. Right now we're given it. We have the answer in terms of kilometers per minute, but the answer over here is supposed to be in miles per hour. So we have to convert kilometers into miles and minutes into hours. So it looks like it's going to be fairly simple here just to do, I'm just going to do 2 quick conversions and we'll have it. So let's get rid of this stupid ruler. Okay, so here we go. In red now, my conversions. So I was given the conversion from kilometers to miles. Okay, so I'm just going to write that in there. I'll do it wrong. I'll do what students do. 1 point is what students do all the time. 1.6 kilometers over a mile. What's my error? Sarah, she says we kill off miles. Yes. We will have to, we're trying to kill off miles now, but why won't this kill off miles? Right. So Jacob said, well, the kilometers has to be on bottom to kill it. You're killing it by making it over itself makes it go away. So let's fix this. And if you do that wrong, then now you're really confused. 1.6 kilometers in a mile, and so mile goes on top. So now my green, I always have a green kill pin. So my green kill pin, I kill off kilometers. If it's common to top and bottom, it cancels itself. Okay, now what do I do? Somebody pipe up and tell me my next move. These are all conversions. What's my next move? 60 minutes and 1 hour. Okay, so let's put 60 minutes up here, 1 hour down there, and then my green kill pin, I can kill the minutes. And on the green kill pin, it's also a save pin. You save miles so you don't later go back and kill it. I see students do it all the time. They get the unit they want, and then for some crazy reason they kill it too. So, oh, no, that's friendly fire, man. So hours there. So they go, hey, look, I did it, miles per hour. Now all that's left to do is multiply all the top numbers times all the bottom numbers. So we'll have in your calculator, oops, not my kill pin. We have 330. I don't need units now. I already got units in the end. 330 times 60 on top, and I have 18 times 1.6 on bottom. And then whatever that number is, I don't know. That's I think it's in it 8. Oh no, what is it? I'm kind of curious now. What is that number? Somebody punch it in. I don't have my calculator. Somebody punch it in and tell me, what is that number? It's big. I mean, it's fast. Wow. This is an app. By the way, I'm not making these numbers up. This is how fast. This is in your lifetime. I don't know about my lifetime, but I'm thinking by 2040, in 20 years, this will be, being optimistic here, this will be completed. So 680 to 3 Siggies, 688 miles per hour. And that's the average, you know? I mean, you start at 0, you end at 0, but the average velocity, and by the way, that's called V bar. You put a bar over it, it's called V bar. And that means average. This means average. As opposed to instantaneous, which we'll get to later. All right. So you are probably going to ride on the Hyperloop from Oklahoma City to Dallas sometime in your life, and you'll go at that speed. Crazy. You could actually live in Oklahoma City and work in Dallas, or vice versa. Harry said, well, does it matter if I did the time before the distance? Oh, no. Doesn't matter. You can go either way. You can go time first. The order of conversions does not matter. And I think I wrote that in a couple of help videos. Doesn't matter. It's like saying 5 times 4 is the same thing as 4 times 5. What's the difference? All right. Elizabeth says, well, is it okay if I wrote small notes around the problem? So, or do you want, no. I want all your notes. In fact, Elizabeth, if your tendency is to write notes and do that, because that gives you extra points. I mean, it'll give you, like if you get it wrong, it'll give you partial credit. That'll give you partial credit. Okay, so like sometimes, how about this? And this is true for AP exam as well. So Elizabeth, if you're verbal, you can write stuff out. Sometimes just writing out what you don't understand about it gets you points. Like you say, well, I think I know I got to find my time here, but I don't see how I'm going to, or say you get to the point where all the blue work on this, and then you just kind of, at that point, you got to know what to do. Say, okay, I know there's some kind of conversions here, but I haven't quite figured that out yet. That helps me know that you know something, you know what you don't know. That's what I'm saying. So it's good. It's good. The more you can communicate with me, the more points you're going to get. And so Brennan says, so on 16, we are rounding up. Well, and these are all brilliant questions. So, and really, to be honest with you, I'm being a little cavalier about my, this really should be, if we're going to be real sticklers about it, 690 miles per hour. And the reason is, look at the 18. I'll blow this up. And this is something that's going to come back all year long, but we'll talk about it. But on 18, that's only 2 digits. We go over here and we go, okay, in 330, that's 3 digits, but the 0 is a placeholder, so only 2 significant digits. And then in my conversion, I have 1.6 of 2 digits. So you could conceivably say, really, the better answer is 690 miles an hour. But here's what it comes down to. We are going to drive, I'm going to drive you crazy, and you're going to drive me crazy. Because we're going to be correcting ourselves all the time. Well, you gave me 3, it should be 2. Look, here's the rule of thumb. Unless it's a sig fig problem, which there aren't many of those, but here's the rule of thumb. The rule of thumb says that 3 to 4 digits in an answer, and that is always going to be good for me unless it is a particular sig fig problem, which we're not going to have any of those till probably November. So you're going to be cool with 3 to 4 digits in an answer. Always. Just leave it at that rule of thumb. Okay, so we are down to 20 minutes. Are we done? You guys you're questioned out. We've got 16, 15 we've gone over. You guys, there's no reason why you shouldn't get a perfect score on this. Can we work 4B? Let's look on that. 4B. 4B, okay. We haven't done 4B yet, so yes. And I'm going to erase this, so get out of my way. All right, so 4B, it says, look, I'm going to give you a minute to you do it. You do it on your own first, and then I'll work it with you. At first, you do it. So 4B, write the physics equation. Okay. Oh, man, I made some kind of, I made some spicy burritos tonight for dinner. Fighting back. So I'm going to go with the green on that line. Well, we have a bunch of peppers in our garden, so I stuck in a bunch of extra peppers. And it's fighting back. Oh, I think that stops right there. All right. So that's the line you got to write an equation for. Another 45 seconds on your part, and then we'll talk about it. Keep in mind that those are kilometers and those are hours. So watch your units. Okay, I'm just going to do it right there on the graph and carve out some space. Right there. Okay, you guys have your guess. Let's go. Can we go? Okay. Let's knock this one out. So here we go. I go with low-hanging fruit. I'm a low-hanging fruit guy. So, and this came up on Wednesday. Do we need I's and J's? No I roofs or J roofs because they're not in the problem. If you do, it's okay as long as you don't screw up. Okay, so this is plus 60, and then it's kilometers, so plus 60 kilometers. So that's where I start. And now I find, and this is x, I guess, so x of, and it's t, x of x is a function of time, equals, now I need my slope. Slope, I fall 100, right? 60 to negative 40 is 100. I run 10, well, that's convenient. So it looks like it's the exact opposite slope of the other one, the blue line. Is that right? That's crazy. Hold on, let me see if I can screw up. I dropped 100. I ran 10, right? I dropped 100, 60 to negative 40. I ran from 0 to 10, yeah? So my slope is negative 10. Be careful here. Put your units, watch out, kilometers per hour, not meters per second. Parentheses, times t, like we talked about earlier. And that's it. Hopefully it's what you got. Now, Nathan asks about number 12. Let's go look at it. Oh, well, Nathan, looks like we did that one on Wednesday morning, but there it is. This is from, we went over it Wednesday. How about let's do another one then. Let's just do, since you already did 12, let's do 11. Make sure, even if you've done 11, maybe you did it wrong. So let's take a look at 11. I'll do that in black. Okay. So 11 here says how many kilohertz are in 45 gigahertz. So I'm going to write it out the way that I write it out in the sheet, 45 and the metric sheets. 45 gigahertz is equal to blank kilohertz. HZ is Hertz and named after Heinrich Hertz, 1800s, German. 4.5 times 10 to the yellow box. I gotta have my yellow here, yellow box. Okay, so now you do it. Sarah wants to go back to that problem. Blue line, the blue line, okay, so look, I'm going back here for a second, just to clear this up, because I think Wednesday when I was rushing through it, I think I screwed up too. But the blue line, if you look at it, you can take doesn't matter where you take the slope at. If I want to go the whole thing, let's go the whole thing. Let's go the whole blue line. In that case, my rise is 100 and, let's see, that's 80, 100, 120, 160. And so wouldn't you agree, Sarah, that the rise is from negative 40 to, that's 80, 100, that's 120. It's 120. So the rise is 160. The run is 16. So 165 by 16 is 10. So, okay. Back to Nathan's problem, sort of. So now we go through, we do this, and we do the old routine. We count powers. And since I always write these, proper notation is 4.5, the decimal after the first digit. That 45 becomes a 1 above it. Giga's got a 9 above it. Kilo's got a 3 above it. So I got 1 plus 9 is 10. 10, it says plus here. 10 minus 3 is 7. That should be 7. Okay. Yeah, I think, okay, so Elizabeth, is Elizabeth doing good, y'all? She's asking lots of questions. 3C. 3C? Is there a 3C? Oh, 4C. Okay, 4C. 4C, we're down to 12 minutes here, folks. 4C, now we got the dashed. And she said that the equation on 4C should be x equals blank the kilometers lines on. Right, so in this case, on 4C, we have x we have x of t equals 80. Okay. Now, actually, Elizabeth said x of t, but since, no, that's fine. X of t equals 80 kilometers. Let's leave it like that. That's right. So that's how flat lines are because there is no slope, right? Zero slope. Okay. We got 11 minutes. I'm going to let you go early. I don't know, man. You guys, I think we've pretty much scoured this thing pretty good. We've either talked about all of them or we've done all of them. Now, we haven't done 5, 6, 7, 8, 9, 10. What I would do is I would go ahead and just double check, maybe go on Facebook, double check. Dylan says, do you have to write for 12 seconds after? Oh, hold on a minute. Dylan brings up a good point. I'm going to give you a zoom point on that because he said, well, I think what he's inferring is, how do you tell if I'm looking at this equation, if I'm just looking at x equals 80 kilometers, I have no idea how long. And so he said, well, should we somehow show that? You can, but it's not in the equation. You could say if you want to write it out, 12 seconds. I'm not going to count off for that. But it's not necessary in an equation. It's the same thing with the green one. The green one had this. The green one has this for your equation, but nowhere did it say to stop at 10 seconds. Oh, not seconds, 10 hours. Nowhere did it say stop at 10 hours. So that's not that's one thing that's the equation will not tell you is how long, what the duration is. So you have to actually write that out, but you don't have to. I'm just saying that if you wanted to tell the reader exactly how long it lasted. Okay. So 10 minutes to go. Brendan said, can you now go back and show 11? Show 11? Oh. How about instead of doing that one again, let's just do another one. So we can, hey, let's do 10. 10's a pretty good one, okay? Let's do 10. First off, you all, whenever I'm doing multiple choice and I'm working the problem, I don't look at my choices because I'm telling you, that's going to fool you. You're going to jump on a distractor. So ignore the answers. Do this like it was a worksheet. Then find your answer in there, okay? Go ahead. Let me give you a minute to work. I'll give you 1 minute to work number 10 if you haven't already. And then I'll do it. Okay, time's up. So what I do is I'm going for making my partial credit. I know it's going to be 4.8 times 10 to the something. My yellow box. All right. So now I look at this. I go, okay. Low-hanging fruit, right? Microseconds is -6. Milliseconds is -3. And then I go, wait a minute now. It's 0.0048, and I wrote it as 4.8. So I have to compensate because really 0.0048 is really 4.8 times 10 to the -3rd. See, so you're compensating that it's really a really small number. Okay, so we add these up and we subtract it on the other side. So -3 plus -6 is -9, minus a -3 is arithmetic's my problem. So -9 plus 3 essentially, so -6. Did everybody else get that? Thumbs up. Could you go back to number 2? Okay, I'm running low on time. 7 minutes here. Number 2. Okay, so we talked about this. There's also a really good screenshot from, I think, oh God, I don't know what day it was, but one of those where I showed distance and displacement and all. And then I answered, oh, on Facebook. This is on Facebook. This is answered on Facebook. Sophia asked a question on it, and I gave her like 5 answers. So anyway, here's what we talked about on Wednesday morning, and this is actually a tough question. So use a label drawing and correct symbols to help you explain the difference between position displacement. So like, as far as symbols go, these black here, this would be position, right? This would be position. Final position minus initial position. And this is displacement. Now, displacement has a direction. So it is an arrow. So you could, and you probably should, put a vector sign above it. I'm not going to count off if you don't. It's too early on in the year. And it gets to be a pain in the butt anyway. And then, so then what the heck is distance, right? Well, distance is absolute value of displacement. But distance is how far. So if you ask me how far is it to, how far is it from Norman to Oklahoma City, I'd say 20 miles. But I'm not telling you the direction. See, if I say it's 20 miles north, now I'm giving you a displacement. Or I drove from Norman to Oklahoma City, how far did I go? I went 20 miles north on I-35. But if you say, well, how far was that? I'd say it's 20 miles. But I'm not telling you anything about direction. And plus, if I'm going to say to the south is negative, and I say Norman to Dallas, and I say, well, that's the displacement was, I started off in Norman was my X naught. X final was negative 183 miles south. Then my displacement's negative 183 miles. But how far is it? It's 183 miles, absolute value. Because you can't have, there's no such thing as negative distance. Can't have it. Okay? So, okay, oh man, I'm terrible with names. Mr. Shutter asked that question, but if you, whenever we ever get to see each other in person, you can tell me how to say your name. I'm terrible. Maybe I call you TS or something, or TP. Hey, TP. We have to give you something because I'm awful with names. Timothy. I get the wrong emphasis on the syllable all the time. We're down to 3 minutes, so I don't know if we have time to do a problem or not. I have problems. I can encourage you all. I think you all are great for being here. I will go ahead and put this recording on. The good thing about that is I don't really have to. Then I think every problem has been pretty much. I mean, yeah, okay. There's like 5, 6, 7, 8, 9 that we didn't really go over, but I'll put that key up there. Then you're going to grade your own, but that's later. First, you got to turn it in, and then we grade it later. I'll grade it, and when I'm grading it, I'm grading. Did you attempt all the? Even if you're wrong, and you shouldn't be, because we got the daggone answers. But and then for right now, let's just get it turned in by midnight tonight. Finished with all your work, showing all your work, and like Elizabeth says, write me all the notes you want. I love notes. It kind of helps me know what you do and don't know. You could say, your note could say, you didn't explain this very well or whatever. That's fine too. Just communication. I want to communicate with you. And because we can't see each other a lot, this may be the only way we can communicate. Call them Shutter. I like that. Shutter. Well, Shutter. That's your last name. TP Shutter. Shutter. Okay. That's cool. Shutter. Shutter's a cool name. All right. Okay, y'all. I think I'm going to call it off now. You bet. Good. I'm glad it helped. And I think, and we'll continue to do this. Hopefully we'll be able to be together when we do stuff like this, but good. Let me stop sharing. All right, y'all. So I'll see you all. I'll see you all virtually tomorrow or Tuesday. Don't miss the virtual sessions because it's going to be really, what we're covering tomorrow is kind of hard, and all this week actually. So don't miss. If you do, I'll probably end up taping third hour like I did last time, because first hour I'm kind of figuring things out, then third hour I kind of got it down. But we'll see. All right, so I'll see you all. Look for the recording here, but I'll see you all tomorrow or Wednesday or Tuesday. Bye-bye. Bye.